Hi, in this video, we will see SQL indexes. Very important topic. If you want to work with optimized queries, or if you want to write, or if you want to perform query optimization, index would be really helpful. Indexes in the SQL, right, are the data structures that enhance the query performance by enabling the faster data retrieval. So created on one or more columns. So index can be created on the one or more columns, and index acts as a reference point. What do we mean by that? You will get to know. Allowing for efficient lookup operation, right? Efficient lookup operation. So that's all about the indexes. So when you talk about the indexes, you think or you look at the fetch patterns on the queries, right? So in what pattern you are retrieving the data, and by observing that pattern you decide this column is getting targeted many times. So what you do, you just analyze the select statements on which column we are performing the most operations, and on that column you create the index. Well, indexes are good, but you need to create indexes wisely, because lot of indexes may hamper the performance as well, right? Now we will see one by one. We have seen what do you mean by indexes. Now how do you create the indexes in SQL? You create the indexes by means of create index query. So let's do one thing. First drop the DB, drop the database, then create the database, again use that particular database. So we would be needing one table, orders table I will create first. Okay, then one more table I will create. Along with the orders table, I will create the customers table also. Run it, customers table also, and let me delete this block. Okay, so we have created DB as usual. We first dropped the DB, then we have created the YTDB, then again used the DB, created one table, created another table. Look at the table structure. Order ID is primary key, then there is a customer ID int, order ID date, and total amount is the decimal, right? Status is a varchar. So here you can say customer ID int primary key. So here customer ID is primary key, and here order ID is also primary. So we have two primary keys over here, and there is one email which is a unique. So first I wanted to create the index. So how do you create the index? Create index. So how do you create the index? See now, create index idx, we can say, underscore idx underscore. On the last name we can create the index. So copy the, well, absolutely not necessary, you can do anything. Last name on, right? Which table? On customers table, and inside that you need to write a actual column name. So here you can write anything, no problem, right? But generally you should know this index is on which column, right? That's why you write actual column name over here, but not necessary. So here create index idx underscore last name on the customers, semicolon, run the query. Index would be getting created. So if you can see, index have been created. So when you say index have been created, how do you check index have been created? So there is a one query called as show index. So here you can go and show index, and after that you need to write the table name. Show index for which table? Customers table. Show index from, there is a from clause missing, and here you can say, can you see, customers idx last name. Can you see? This is the name of the index. If you see IDX last name, which comes over here, IDX last name, this is on which column? Last name column. Which is on which column? Last name column. Getting my point? IDX last name. Now, if you see over here, create index, right, creates the new index on the table, on given table. You have given only once. You have written create index only once. But if you see, there are 3 indices have been created on the customers table. 3 indexes have been created on the customer table, but you have written only one create statement, which means that if you see here, I have written primary keys and unique constraints automatically create indexes to enforce uniqueness and fast access to the rows. See, primary keys automatically create the index. Unique constraints automatically create the indexes. Now here, if you see, a last column, or this column, index type is a B tree. Now what is B tree? In the context of databases, B tree is a short form for balanced tree. Balanced tree is a type of data structure used to store and manage indexed data efficiently. B trees are commonly used as index structures in database system to facilitate the fast retrieval. Now, go to your book for data structures and algorithm and see how balanced trees work exactly. So that data structure is used over here, right? And write it in the comment box why only balanced trees have been preferred by database engineers. Why not other structure? Write it in the comment. B trees, why only B trees are used? Remember that B trees are nothing but what? Balanced trees. For the fast retrieval, we use the balanced trees internally. You don't need to do anything. Internally, it happens. So, to give a proof of this statement, primary keys and unique constraints automatically create the indices. You might be thinking that you have written, that's why all 3 have been created. To show you, on the orders table, we didn't create any index, right? Let's try to show index from orders. Okay, what is this? It's a markdown. Show index from orders and run it. Can you see? There is only one primary key and index name is a primary, right? On the column order ID. For the primary key, unique constraint, and your given column, indexes are created. But for primary and the unique constraint, indexes are created automatically. That's what we have discussed, right? So far, we have discussed 2 things. That is nothing but create index. We have created the index, right? And we have checked the index, show index from the table name, right? Let's try to create the composite. Index. What is a composite index? In some cases, you may want to create the index on multiple columns. This is known as composite index. For instance, let's say you have, we have actually, don't worry about this statement. If your index is on the multiple tables, we call it as the composite index. Okay. Now, orders table will come into the picture. So here we can say create index on the orders table. What's the query? Tell me for creating the index. Create index, index name, and on the orders table. Create index idx, we can say, upon underscore cst underscore ord underscore dt, date, customer order date, right? On which tables? Orders tables. On which columns? Two columns. Just copy paste the columns. Customer ID. We need to combine these two. Customer ID and order ID. Customer ID and the order ID. Okay. Let's run it. Can you see? We have created the index. Let us see. Show index. Show index. Okay, it's a markdown again. Show index from orders. Run it. If you see over here, customer ID and order ID, if you see, separate two indexes have been created. Separate two indexes have been created. See here. Just a minute. So here, when you say composite index, when you say composite index, when you create index, if you see create index idx cst on this, see the result, record 0 duplicates, server status 2. So you are saying that whenever there would be a select for customer and order ID, customer ID and the order ID, right? Customer ID and the order ID, this index will come into the picture. Right? That's how your composite index will work. That's how your composite index will work. This is how. If you have any questions, you may ask it in the chat box, right? Sorry, in the comment box. But this is how composite index will work. Now here, there is one thing about indexes you need to remember. See here, it is essential to create index on columns that are frequently used in the search conditions. Remember that. And join operations to optimize the query performance. So remember that first you need to analyze which column you are accessing a lot of time, and you need to create index over there. However, creating too many indexes on the columns with low selectivity can consume the extra space and degrade the performance during the write operation. Remember that. During what? Write operation. Remember that. You need to select the column wisely that is getting frequently accessed. And then you need to create the index properly. Getting my point? So you need to remember this thing about the indexes, right? So here what we have seen, how to create the index, how to create the composite index, and weaving an index. Now see, let's try to, well, presently we don't have any data. But whenever you have a huge amount of data, presently we don't have any data, it will do nothing. Can you see there is no data? That's why it is not showing. But if you have 1 lakh records, and into that 1 lakh records, last name is the column where you have created one index, the result would be too much faster than the table which is not having any index, right? Just as an example, I have shown you this thing. We cannot create the 1 lakh records. It will take too much time. I can show you that as well. Not an issue. But I want you to try that. Create a dummy data. Create a toy data of 1 lakh records. Take a help of ChatGPT. Create the records and try to fire the query without index and with index. And please let me know the results. I'm very sure that you will see the difference very clearly, right? This is how you will use. So last name, remember that is a column where index is there. Getting my point? Hello? Okay. So this is what we have seen in the indexes. Weaving the index, using the index, composite index, creating an index, and theory we have seen over here. Everything is updated in the notebook. You may check it and let me know for your queries and concerns. Also, if you have understood this session, please write it in the comment box. Thank you. Let's meet in the next video. Thank you.